Hello all, welcome back. Now we are going to look at IP addressing and endpoints, and this is the second lesson of the virtual networking module. We look at this lesson, we will start looking at what are the IP addressing methods available, particular public and private IP address, and we will see a demonstration of how to manage the IP address using PowerShell. And then we will look at what are service endpoints and what are the Azure services which supports service endpoint, and how to secure storage access using service endpoints, and finally a demonstration of service endpoints. So when we talk about IP addressing, there are two type of IP address available. One is the private IP address and another is the public IP address. Whenever we want to try to connect to resources such as Azure Virtual Network or our on-premise networks, or connection within or through VPN gateways or express route. So that is where we want to connect the service privately without navigating it to internet. So in this case, we will use our private IP address. And for services which we need to connect through internet or public facing, then we need to use public IP address. Or other way around, if we want to expose our application to internet, we need to make public IP address for our application. Or if we want to make our application accessible only to the intranet or within the network, then we need to have private IP address. So there are two type of IP assignment available. One is what we call static and another is dynamic. So dynamic is the default behavior. So whenever we are trying to assign a new IP address, it will pick the unused IP address from the pool and it will assign it to the networking interface. And whenever we want to release it or shut down the resources, it will release the IP back to the pool. And if some other resources need that IP address, they can be reused. So that's what we call it as dynamic IP address. And the other addressing mechanism is what we call static IP addressing. In this case, we will create a new IP address and we assign it permanently to the resource, either it be network interface or the load balancer. Once we create the IP address and we can assign it permanently, then in this case, even if the resource is shut down, the IP address is still retained. So the next time when the resource comes up online, it will use the same IP address. So there are some scenarios in which we can use static IP address, and in some scenarios we can use dynamic IP address. For example, if we want to have a scenario of DNS resolution, so in this case, whenever we want to hit a URL, it will have a DNS resolution to an IP address. And if the IP changes, in this case, we might need to go back and update the DNS record for the new IP address each and every time. So it makes sense to make this as a static IP assignment for such scenarios. And other scenarios maybe if our security is based on say IP address, restricting it in firewalls based on IPs, then it makes sense to make the IPS permanent or the static. Then we can just use this IP address for security. And there are scenarios like we can use IP binding SSL, and in this case, even if the IP changes, then we need to bind it again. And other final scenario may be if we use role-based servers like DNS or the domain controllers, then we don't want to change those IPs. So since they are fixed, we need to have a static IP assignment as well. If we look at the public IP address applicability and assignment, we can apply public IP address to multiple networking resources like network interface card for the virtual machine, or we can assign it to the public load balancer in the front end configuration, or we can assign it to VPN gateway IP configuration, or for the application gateway we can assign it in front end configuration. And for virtual machine and the load balancer, we have option of both assigning dynamic and static, but for VPN gateway and application gateway we can't retain the IPs, so it is always dynamic. And for private IP address, again we can assign it to some of the resources like virtual machine, or the internal load balancer, or the application gateway. And here we have option to retain private IP address as static as well, so we can use both static and dynamic assignment. So whenever a new IP address is assigned, it always picks the next unassigned IP address. Say for example, in a virtual network which has an assigned IP until 10.0.0.5, and when we are starting a new virtual machine, it will by default picks 10.0.0.6 as the next available IP address, and it will assign to the network interface. And one thing to note in Azure is that IP addresses are never managed within the resources. Whereas in on-prem world, we can configure the network interface as a configuration file, and we might restart the VM and it will be applied during the next restart. But in Azure, everything is managed outside of the resource, and it can be made through by directly interfacing with Azure management uh, APIs or the tools. So before jumping into demonstration, one thing I want to mention is that whenever we are trying to create a new IP address, we have an option to choose the performance tier, either the basic or standard. And there, based on these choices, there are some functionalities available in each one of those ones. Say, for example, if you look at IP assignment part, we can use both static and dynamic IP assignment when we choose basic. But if we choose standard type load balancer or the standard type IP address, it can be only static IP. And it is particularly useful in assigning to standard load balancers and options like zone redundancy as well. Now we will switch back to PowerShell to have a demonstration of how to retrieve a private IP address of a VM and how to change the assignment from static to dynamic. So now we are looking at PowerShell, and now we try to get the network interface information of a VM. So we are looking under the resource group VM-RG, and we are providing the name of the virtual network interface. And if we execute get AZ network interface command, we get the output. If we inspect the output here, we get the name of the network interface, resource group, location, and the provisioning state succeeded. And particularly if you look at the IP configuration section, here we have the private IP address available as 10.0.0.4, and the IP address allocation is static. So we can now see that this private IP address assignment is static one, and if we want to release the static IP address assignment, we need to change it to dynamic. So coming to the PowerShell, so we use the same commandlet and store it as a variable called $nick, and under the IP address configurations, we can set the private IP allocation method to dynamic, and once we set this to dynamic, we can enforce these settings using set AZ network interface, and we'll pass the updated network interface configuration. So once we execute this, we are now changing the IP configurations dot private IP allocation method to dynamic. Now the execution is successful, and now if we inspect the IP configurations, under the IP configurations, private IP allocation method changes to dynamic. So this is how we can release an IP address. Now we will look at service endpoints. Service endpoints normally provides the identity of our virtual network to a particular Azure service. So for example, if we have a publicly accessible service like Azure Storage, we can limit the network access to that service only from specified subnets and IP addresses. That's what service endpoints do. So it also helps in increasing security of the Azure services. Say for example, instead of accessing the traffic from public IP addresses through internet, we can limit it only from the private IP addresses within the specific VNet. So here we don't really need to go through internet, and hence the traffic is secured. So normally inside a virtual network, if we have user-defined routes specified for a subnet, then in case of forced tunneling, the traffic will go through on-premises. But if we have configured service endpoints, some of the traffic which is destined to a particular Azure service will not follow that long route of forced tunneling. It will directly go through Azure backbone without touching the internet, and hence there is even no need of tunneling back to on-prem. So hence this provides optimum routing for specific Azure services traffic, and it will use Microsoft backbone instead of the internet. And the setup is simple from both the virtual network side and the Azure service side as well. So we don't really need to have any public IP addresses or the gateways. We can just enable on both sides, and it's as simple as that. If we talk about the services which have those capability, service endpoints are applicable to services like Azure Storage, Azure SQL, Key Vault, Cosmos DB, etc., which is publicly accessible platform as a service options. So, in case of let's say storage, we are restricting the storage to be accessible from only within the particular subnet, and all the traffic which is outside of the subnet will not uh, uh, will not be allowed. And not all the Azure services have this capability at this point, but the list is increasing day by day. So if we look back after some time, the list may vary. The thing we need to keep in mind is that which service supports the service endpoint capability, and we can enable those service specific to the particular subnet. If we take an example of Azure Storage Service Endpoint, we have to configure this service endpoint capability in both sides of the service. For example, from the subnet side, we need to enable what is the service endpoint which we need to enable. Say, for example, in this case, we need to enable Azure Storage as the service endpoint from the subnet side. And coming to the storage account side, we need to specifically select the particular VNet and subnet to enable this service. So it should be both sides, and we have great documentation for each and every service endpoints available. Say, for example, we have detailed documentation of service endpoint for Azure Storage or Azure Active Directory, etc. So now we will switch back to a demonstration of using a storage account and how to access the files from the storage account, and we will enforce the service endpoint, and we will try to access the file again to check that is successfully blocked. Now we are into Azure portal, and we choose a storage account which is already created, and we'll check some files exist. So under the blobs and under the container one, we have a sample file called azure deploy.json. Now what we can do is we can create a shared access signature for the entire storage account, and we can access this storage account using this shared access signature, and we will enforce the service endpoint from a particular subnet, and then we'll come back and check whether this access works. I keep every parameters as default. I enable access for everything, and we generate a connection string, and using this connection string we are going to access the storage account publicly from Storage Explorer. So Now we are trying to add an Azure account, and we have a connection string, so we will choose the connection string option. And we will name the storage account, and it will list the details, and we click on connect. And we are able to see the storage account successfully. So if you look at the blob containers and the my container one, we are able to see the file. So in this case, we are trying to download the file as well, and download is successful. So now we will switch back to Azure portal, and first thing is we will select a particular VNet. Let's say, for example, in this case, my VNet-portal, and under this we will select a particular subnet. So there is an existing subnet called subnet-1, and we will restrict the storage access to this particular subnet. So inside this subnet, there is an option called Service Endpoints, and we will enable Microsoft storage for this particular subnet, and we will click on save. Now we have enabled service endpoints from the VNet side, and we will come back to our storage account. And under firewalls and virtual networks, we will select the particular VNet which we have enabled service endpoint. So we can click on add existing virtual network, and we choose my VNet-portal and the subnet 1. We click on add, and we should be able to see those details. And since we have already enabled endpoint on the other side, it shows endpoint status as enabled. Additionally, if you want to add some of the public IP addresses, we can add those as well, but at this point we don't want to add anything. So we'll click on save, and now the settings are saved successfully. Now we will switch back to our storage explorer, and we can refresh the settings. Now we are not able to read the containers, so basically we denied the access. So this is how we can configure VNet service endpoints to an Azure public service. Thank you.